So, part 4 in Spliced Precast Girder Erection Sequence. The erection sequence starts by these two first construction stages corresponding to the abutments and bends construction and the installation of the temporary shoring towers. These stages can be included in the analysis as well, since the model is prepared for it. Here we are studying just one precast girder, and for simplifications, we are going to start the construction stages at the next stage. So erect the on-sheet segment 2 and 4. At this stage, girder has a similar cantilever behavior. So it's considered the self-weight of the segments 2 and 4 installed one first post-tension tendon that will help controlling the tension at the top of the girder, and is calculated the creep and shrinkage effects. So the time interval for creep and shrinkage is considered being 20 days. This construction time will correspond to the schedule plan on the site for the bridge construction and should be adjusted to it. So at stage 03, the pier, definitive supports, and the shoring towers, temporary supports, are activated on the structural system. The left diagrams that we are seeing correspond to the stress results obtained for the summation permanent load case at the top fiber at the top and at the bottom fiber at the bottom of the girder. The right diagram is the bending moment for the secondary forces of the summation permanent load case. So let's see the next video. So in stages, analyzer stages, schedule actions, we have the construction stage 03 at the top table, and at the bottom table, we have the commands or actions that will be run. In stages activations, we can look at the elements activated. So the girder element segment 2 and 4, the pier definitive supports, and the shoring towers temporary supports. In main view, we can go to load cases to present the load cases defined for this stage. So we can see the self-weight 03 for the segments 2 and 4, and the PT 03 for the pre-stress for the post-tension tendons 101 and 102. So when we are stressing post-tension tendon, the schedule actions that need to be run are the stress, the caulk, and the grout. So stress to run the tendon loads and to take into account the way that the tendon is stressed. Caulk to calculate the secondary forces on the structure, and the grout for the grouting consideration. So now we can run the model, and during the run, we can introduce some plots for seeing the results obtained in each construction stage. That is very useful. So at the bottom right, we can see the profile for the first tendon. So we can also display in the main view only the active structure and present the obtained results. We can see total results, secondary results, and primary results. So all the options are available. Stage 4, attach steel strong backs and direct the end segments. The load case is considered is the self-weight of the new segment, segments 1 and 5, the pretension tendons of the end girders, and the creep and shrinkage effects. And the stress diagrams and the bending moment at this stage are presented in this slide. So let's see the next video for the stage 4. So in this case, the stage 4, it's considered the self-weight. So the pretense schedule action for activating the pretension tendons and the creep. At the activation, we see now the eye girder end segments, the definitive bearings at the abutments, and the steel strong bags activated at the extreme spans for transferring normal and shear forces. So in main view, we can display the load cases for this construction stage too. So we will see in this case the SW04 and the PT04. So the pretension tendons in this case are coincident with the cross-section edge, so not too much visible, but they are there as we are going to see. So run the analysis. So see the first tendon and the pretension tendons at the extreme segments. And we can look at the results obtained too. So attach steel strong backs and direct the drop in segment 3. So it's exactly the same procedure done for segments 1 and 5, but now for the middle span, segment 3. And the results obtained are the ones presented in this slide. Stage 6, cast closure pours. So it corresponds to the self-weight of the wet concrete for closures and continue consider the creep and shrinkage effects during the construction stages for the 20 days of time interval and the results obtained. So here we can see that in the stress diagrams, and mainly for the bottom fiber at right, we can clearly see the difference in stress results at the beginning and at the end of this construction stage, stage 06, due to the 20 days of creep and shrinkage effects. Stage 7, stress tendon 1 and release the uplift restraints. Now we are removing the temporary supports for the shoring towers by using the load type demo and install the first continuous post-tension tendon on the concrete girder. Consider the creep and shrinkage too. So at this stage, we have a continuous system working, and let's see the next video about how to remove the temporary supports. So at stage 07, it's calculated the load case RAM01, install the first continuous post-tension tendon with the stress, calc, and grout, and consider the creep and shrinkage effects. At the stage activation, so we are deactivating the temporary shoring tower supports and the steel strong backs for longitudinal movement. We can go to load cases and edit the load case RAM1 where the load type demo is used for transferring the temporary reactions of the total permanent load case to the active structure. So it's necessary to specify the load case name where the reactions were previously stored. So run the model. And we can see now the first tendon, the end segment, the middle segment, and the first continuous tendon. And we can display results in the main view for secondary forces. So we can use also different scales if we want to increase or decrease the drawing. So the program has that possibility. Stage 8, central slab pour. So where is considered the self-weight of the wet concrete of the first deck slab construction sequence. So we have chosen two construction stages to build the deck. One first stage for the central span and zone over the piers, and the second one for the end segments. So at this stage, the composite element is still not active. So on the results, we can see one increase of the tension, in this case at the top fiber of the eye girder. Stage 9. Stress tendons 2 and 3 and remove the steel strong backs. Because we are working with a 3D model for an eye girder, at this stage we have the composite elements active at the middle and at the middle span and the zone over the piers, and we can now remove temporary supports for transversal movements. And we install the tendon 2 and 3 and continue consider the creep and shrinkage effects. And the results obtained, so we can see one more uniform compression in the stress results on the eye girder after the tendon 2 and 3 are installed. So stage 10, end segments, slab pour. So for the self-weight of the deck wet concrete on the extreme spans and the correspondent obtained results. Stage 11, stress tendon 4 and superimpose dead load. So it's installed the last continuous post-tension tendon at the composite section and calculated the superimposed dead load. So at this time, we will get the creep and shrinkage effects at the final of the construction and before the bridge is open to the traffic. And the stress results are the ones presented with no tension on the girder. Stage 12. It's the last construction stage and stands for the long-term effects due to the creep and shrinkage action since the final of the bridge construction till the 10,000 days. And here we can see the permanent stress state of the spliced precast eye girder. So at the bottom diagrams, the long-term effects in terms of stress results at the top fiber at left and at the bottom fiber at right, and the differences between the two lines will represent the long-term losses that happen in our structure. So let's see the next video with all the run. So we can see now all the construction stages introduced, the traffic calculation, the envelopes and combinations. So we run the fiber stress check for the service envelope and also do the ultimate check capacity by using the ULT-SUP schedule action that we are editing here. So we can run the analysis and see all the construction phases that were introduced in our model. So the first tendon, the pretension tendons and segments, the middle segment, the first continuous post-tension tendon, the second and the third continuous tendon, and the fourth, and all the tendons installed in our eye girder. So we can see the final stress state on the eye girder for the service envelope with the two types of diagrams available to the user. So by RM sets definition at the top right and bottom left, and the other two by plot containers definition. And we can see now the ultimate check capacity results with the diagrams for the longitudinal bending moment MZ on the I girder top right with the split results, and the bottom left for the composite section with joint results. So I have here one more video that I would like to present. That is the possibility that RM Bridge has to study simultaneously the one beam analysis and the bridge deck form with the 4 composite concrete girders. And all the information that was introduced in terms of the cross section. So with the tendons geometry, reinforcements, stress points, etc. So all the schedule actions are exactly the same that we presented before for one girder. The only thing that the user needs to do here is to introduce the deck elements on the load cases, in this case, for running simultaneously the 2 models, and to activate also the bridge deck elements in the stage activations. So we can now run. So the plot containers definition for the plot diagrams can include the bridge, the deck bridge elements too, or we can produce a different plot diagrams to separate both models if it is the case. And we have the capacity check in both structures.
Thanks for watching. If you found this video helpful, please give it a like and share it with others. If you want to see more like it, please consider subscribing to this and Bentley's other channels. Thank you, and see you next time.